Hello, it's Dr. Daystorms once again, and I wanted to briefly touch upon a topic that the current edition of your textbook doesn't address here, and I'm not for sure why they don't. It just makes sense for us to go over it right now. Because there are times that you're doing these metathesis or these exchange reactions in an aqueous solution, and one of the products given off is a gas. And so I want to discuss what those kinds of reactions are and also discuss how you can predict whether or not it's going to occur. So first, let's just give this example video. I have to apologize that it has an Ohio State emblem on it.
In this demonstration, we're going to observe some properties of chemical reactions. In the 5 flasks in front of me, we have 1 molar concentrations of acetic acid, and there's going to be equal volumes of each in the 5 flasks. In the balloons on top of the flasks are 4, 8, 16, 32, and 64 grams of sodium bicarbonate. This reaction is the classic vinegar baking soda reaction that's going to produce a gas. So we're going to collect the gas on top of the balloon, and we're going to compare the relative amounts. So as I dump the sodium bicarbonate into each container, we can see that as we add 4, 8, and 16 grams of the sodium bicarbonate, the balloons are going to be different sizes. So as we can see, after this reaction completes, we roughly have double volume going from 4 to 8, and then from 8 to 16 grams for this particular reaction.
So, some of these metathesis reactions don't give what you expect as a product. Instead, one of the products decomposes to give another gas product, okay? And usually we're talking about carbon dioxide or sulfur dioxide. So in these examples here, you would expect calcium and chloride to hook up, switch partners, which we get that. It's calcium chloride is an aqueous product. And then you'd expect the other product to be HCO3, like a hydrogen carbonate. However, the hydrogen carbonate decomposes to form H2O liquid and CO2 gas. CO2 gas. Okay? And so it's this gas that gives the fizzing or the bubbling reaction. Likewise, we can see where, let's do an example here with the sulfite with hydroiodic acid, and you'd expect the hydrogen to hook up with the sulfite. But once again, it decomposes to give off water, and sulfur dioxide is a gas. Sometimes the reaction from the metathesis product will be exactly what you think. So, for example, here we have sodium sulfide, which is aqueous. We add in sulfuric acid. We get our sodium sulfate. It's an aqueous solution, but a gas is given off. And let me tell you, you'll definitely want to do this in the fume hood because hydrogen sulfide smells like rotten eggs. So how can we know when to expect these types of reactions? Hopefully you see a form of some sort, or a pattern here. Anytime where a hydrogen carbonate is one of the expected products, or hydrogen sulfite is an expected product, you can expect that this can decompose down to make water and carbon dioxide. Please note, carbon dioxide. Please note that this is not a balanced reaction. Likewise, we can have water and sulfur dioxide. And then the other one to expect is hydrogen sulfide, which is a gas. Okay, so these are the ones that you may come across right now in your lab experiments or in examples in the book or on quizzes or exams. hopefully this has helped explain a little bit about a type of metathesis equation that you come across when you get a product that you weren't expecting. I'll see you in class.